For 80 long days, London lived in a state of dread that seemed designed to break the human spirit. Every sunrise came with the knowledge that somewhere across the Channel, a launch crew in occupied France was fueling a new kind of terror. The British public could hear it before they ever saw it, a mechanical buzzing in the sky, like an enormous motorbike tearing through the clouds. The sound meant a V-1 was overhead. The moment that sound stopped, there were only seconds left. A heartbeat, a breath, then an explosion that shook windows, shattered streets, and left entire neighborhoods in ruins. Few people in London knew that their salvation would eventually come not from a secret Allied aircraft, nor from a daring commando raid, but from a tiny, hand-sized American invention buried inside the nose of a simple artillery shell, an invention that Germany's top physicists had already declared scientifically impossible. Yet it was this impossible device, the American variable time fuse, known simply as the VT fuse, that would dismantle Hitler's V-1 campaign and leave German scientists genuinely unable to understand how it happened. The first V-1 to strike London arrived at 4:15 a.m. on June 13, 1944, just 1 week after the D-Day landings. It roared across the early morning sky before plunging into the city and detonating with an earth-shaking blast. 6 people were killed instantly, 30 more were injured, over 200 were left homeless in minutes, and this was only the beginning. The V-1 was the world's first practical cruise missile. Unmanned, carrying nearly a ton of explosives, and powered by a pulse jet that pushed it at over 400 miles per hour. It was designed to bypass every traditional air defense method the British had used during the Blitz. Hitler and his inner circle believed the V-1 would break British morale completely. London had survived the Blitz of 1940, but the V-1 was something entirely different. It didn't need pilots, it didn't need dogfights, and it could be launched in waves day after day without risking a single German airman. German engineers were confident, perhaps too confident. Major General Walter Dornberger calculated that even if only 25% of the V-1's launched managed to hit London, the total explosive tonnage delivered would exceed the Blitz at a fraction of the cost and with no pilot losses. That wasn't optimism, it was mathematics. Pieneman's leading scientist, Dr. Robert Lusser, had run the numbers himself. According to his calculations, the interception of a V-1 by traditional means was statistically impossible. The missile flew too fast and at an awkward altitude around 0 to 30 feet. Too low for high-altitude guns to be effective, but too high for light air guns to reach reliably. Fighter pilots who tried to intercept the missiles quickly realized the danger. They had to dive behind the V-1 and close to within 200 yards to fire effectively. At that range, if the V-1 detonated, the fighter would be destroyed along with it. Even worse, the tiny time fuses used in AA shells required precise manual settings and allowed only a narrow 30-second firing window. A miscalculation by even a fraction of a second would cause the shell to burst harmlessly in empty air. The Germans used the same technology for their own artillery. They had no reason to imagine the Allies possessed anything different, and so, to the German High Command, the V-1 seemed as unstoppable as it was terrifying. In London, the terror only grew. The distinctive sound of the V-1 became a grim psychological weapon. Londoners learned to freeze the moment they heard the drone cutting out. That sudden silence meant the missile's fuel had run out and the V-1 was diving. People would look up, waiting for the explosion, hoping it wouldn't strike their street, their home, their loved ones. During those first weeks, the Allies could shoot down only about 24% of the incoming missiles. It wasn't nearly enough. Neighborhoods were shredded, and the sense of helplessness was overwhelming. Then something changed. In late June, the interception rate began to climb, quietly at first, almost unnoticeably. But by early July, the numbers were no longer simply improving. They were skyrocketing. British gun crews reported destroying more than half of all incoming V-1s, then 2/3, then more. Yet German command knew they had not changed their missile design. Their launch accuracy had actually improved, and still, V-1s were being cut down at a rate that defied all prior calculations. Reports from observers on the French coast were even stranger. Watchers swore they had seen V-1s explode in midair from near misses, sometimes detonating 50 to 100 feet away from where the shell had burst. A near miss wasn't supposed to do anything to a V-1. It required a direct hit to destroy. German analysts dismissed the early reports as exaggerations or errors, but the British continued to report kill ratios that seemed mathematically impossible. Their shells per kill ratios plummeted. The gunners themselves didn't understand why, only that something in their favor had shifted dramatically. Oberst Max Wachtel, commander of the entire V-1 offensive, was alarmed. He ordered inspections of the launch ramps, recalibrations of the gyroscopes, and even test firings over German territory. Every missile performed flawlessly. The weapons were not malfunctioning. The problem, or the mystery, existed only when the V-1s crossed the channels, specifically when they approached the dense ring of British anti-aircraft guns known as the Diver Belt. Wachtel began to suspect sabotage or some unknown Allied countermeasure. But strangely, no physical evidence ever surfaced. No recovered Allied shells, no captured electronics, no strange fragments, nothing. The truth was sitting inside the nose of every American-made A shell being fired at the incoming missiles. A device with a deliberately uninteresting name, the variable time fuse. It sounded like just another timing mechanism. But the British and Americans had used that name on purpose to mask the fuse's true identity. It wasn't a timer. It was a proximity fuse, a tiny, self-contained radio system that could sense when it was near a target and detonate automatically. Inside that small metal nose was a miniature radio transmitter, receiver, vacuum tubes, an antenna, and a power source. As the shell flew through the air, the transmitter continuously emitted radio waves. When the shell got close to a solid object, like the steel fuselage of a V-1, the waves bounced back, distorted slightly by the Doppler effect. The fuse detected that distortion instantly, triggering a thyrotron switch that set off the detonator. The explosion happened at the perfect moment, close enough to obliterate the target without needing a direct hit. Suddenly, the mathematics of air defense had changed completely. A shell didn't need pinpoint precision. It just needed to get near the target. German scientists had long ago concluded proximity fuses were impossible. They had examined more than 30 different conceptual designs and rejected them all. The obstacles seemed insurmountable. First, no one had ever managed to miniaturize a complete radio set into something small enough to fit inside an artillery shell. More importantly, no existing radio component could survive the shock of being fired. Artillery shells experienced up to 20,000 g of acceleration and spun at up to 25,000 revolutions per minute. German experts famously joked that expecting a delicate radio transmitter to survive that was like firing a grandfather clock out of a cannon and hoping it would keep time. America, however, did the impossible. The effort was spearheaded by Dr. Merle Tuve at the Johns Hopkins Applied Physics Laboratory, who oversaw a vast collaboration involving universities, corporations, and government labs. Companies like Sylvania adapted miniature hearing, aid vacuum tubes, and encased them in shock, absorbing materials like wax and plastic, making them durable enough to endure launch forces. Engineers developed an ingenious glass ampoule battery filled with electrolyte that activated only when the shell was fired, using the acceleration to break the ampoule and wake the circuit. It was engineering alchemy, a fusion of physics, electronics, and raw creativity. By the summer of 1944, American factories were producing 40,000 proximity fuses every single day. The scale was staggering. More than 110 factories contributed to production, each working on different components to maintain total secrecy. Most workers didn't even know what they were building. At the Crossley Corporation alone, once a manufacturer of radios and refrigerators, 10,000 workers produced 16,000 fuses per day at peak capacity. By war's end, the U.S. had built over 22 million proximity fuses at a cost exceeding $1 billion in 1940s money. In 1 month, America produced more VT fuses than Germany built V-1s during the entire war. This industrial miracle was matched by tactical innovation. The British concentrated nearly all their anti-aircraft guns along the southeastern coast, forming the infamous diver belt. Its purpose was simple: create a solid wall of fire far enough from London that unexploded shells would fall safely into the sea, protecting both civilians and the secrecy of the VT fuse. The Allies paired the new fuses with the American SCR-584 radar system, a highly advanced unit capable of tracking V-1s automatically and directing gunfire with incredible precision. Gun crews no longer had to guess distance, speed, or timing. The radar tracked, the system computed, the guns fired, the shells detonated automatically. The result was devastatingly effective. In late August of 1944, the diver belt achieved its most remarkable day. 82% of all incoming V-1s were destroyed before reaching British soil. Missiles that had once slipped through with ease now exploded in midair, shredded by proximity bursts that detonated within yards of their thin metal skins. No matter what the Germans tried, low-altitude runs, high-altitude arcs, nighttime launches, mass waves, nothing worked. The V-1 campaign was collapsing. Inside German command, frustration turned to desperation. Crisis meetings were held as the interception rates climbed to levels once thought impossible. Oberst Wachtel still suspected sabotage or invisible Allied counter-technology, but he could not explain why no physical evidence ever appeared. The irony of the war became almost comical. During the Battle of the Bulge in December 1944, German troops captured an entire U.S. ammunition depot stocked with thousands of proximity fused shells, but because German physicists still believed such a device couldn't possibly exist, they never bothered to examine the shells. They dismissed them as standard rounds. Scientific arrogance had literally blinded them to the truth sitting in their own hands. When the war finally ended and Allied officers revealed the VT fuse to their German counterparts, the reactions were almost disbelief. Some German scientists were stunned. Others simply shook their heads, acknowledging that the Allies had achieved what they had considered impossible. They admitted the Americans were at least a decade ahead in the required fields of miniaturization, materials, and electronics. Dr. Merle Tuve later remarked that the real key to success wasn't just technology. It was the open, flexible, collaborative culture of the American scientific system, which allowed experts across fields to work together freely. In Germany, rigid hierarchy and compartmentalization stifled such innovation. The impact of the VT fuse went far beyond the V-1 war. It served as what historians call a multiplicative technology. Instead of inventing a whole new weapon, the Allies made their existing weapons 5 to 10 times more effective. The shells per kill ratio for anti-aircraft guns, once as high as 2,500 shells for a single downed aircraft, dropped to roughly 100. In the case of the V-1, the improvement was even more dramatic. By the time the V-1 campaign ended, approximately 9,500 missiles had been launched at Britain. Roughly 2,500 made it to Greater London, still a devastating number, resulting in over 6,000 civilian deaths. But without the VT fuse, British analysts estimated the casualties would have been at least 4 times higher. General Frederick Pyle, head of Britain's anti-aircraft command, later stated plainly that the proximity fuse was likely the single factor that saved London. When the device was finally declassified in August 1945, the U.S. War Department ranked it as one of the 2 most important technological triumphs of the war, second only to the atomic bomb. It was small, invisible, and almost never discussed in wartime newspapers. Yet in many ways it embodied the true industrial and scientific power that won the war for the Allies. Germany poured resources into hand, crafted wonder weapons, V-1s, V-2s, jet fighters, each expensive, fragile, and unable to be mass-produced. America built a tiny device that multiplied the effectiveness of millions of conventional shells, and then produced it by the tens of millions. The legacy of the VT fuse can be seen in every modern smart weapon and air defense system. Radar, guided missiles, laser-guided bombs, and anti-missile interceptors all trace their conceptual lineage back to the moment when a simple artillery shell learned to sense its target. In the end, the victory did not belong to any single machine, but to the collective genius of thousands of ordinary Americans, scientists, factory workers, engineers, soldiers, who believed that impossible problems could be solved with creativity, collaboration, and sheer determination. If you enjoyed this story of innovation, history, and the invisible technologies that shaped the modern world, make sure to like, subscribe, and share. And don't miss our deep dive into the legendary P-51 Mustang, the fighter plane that changed the course of the war in the skies over Europe.